Okay class, we're going to go through your SparkFun Inventors kit and just a little intro video about it and the guide to it. So you'll get a kit, you'll purchase your kit, and it comes with hardware and it comes with a paper guide, as well as there is a digital version of the guide that it's referenced as a PDF in our Canvas site. So I have the digital version of the guide up here. I'll hold up the paper guide as well here. So go over to the overhead camera. Your kit should come with this paper guide. So this paper guide is the same thing as I'm showing as a PDF form. Yeah, so let's go to the guide and talk through it. Your boards that you have going, do a couple of initial to your Arduino, and that you can get the software loaded up. So in this class, again, you won't write any code, all the code comes with it, but you have to get it in the right spot on your computer and talking through the right interface to the card. So this is your guide. What I want you to do in getting started to make sure everything's okay is start reading at the beginning of the guide. Don't skip any pages. The most common questions we get is like, oh yeah, it was on page 4, didn't you see it? Just read through, take your time. This is fun. This is the fun part. You get to build stuff. This isn't just a class where you have a bunch of book problems. You get a class where you get an awesome kit. You can learn about Arduino, microprocessors, learn about how to tinker and make things on your own. So this guide is very thorough. It takes you through a lot of stuff. So take your time, read through it. There's an index in the guide. We're not going to do all 16 circuits, but we're going to do a number of them. But we're going to start here at the beginning, getting started section. What's the breadboard platform? A computer for the physical world. It's really neat because you learn about inputs and outputs. A lot of what electronics or any physical item that's moving around works on now are little tiny microcontrollers, especially for tinkering and doing your own inventions or automating systems or setting up your own solar panel. You need to learn a little bit about electronics and circuits to make these things work that you have ideas in of your head. So information about the breadboard's here. Some cute little cartoons about what it can do. I mean, drone control, robot control, bug zapper. Oh, what is this? These are like rocket shoes. That looks sweet. You know, automated cameras. You can make your own plant waterer. Stoplights and controls, coffee maker. It's really fun. So you need to follow these steps to get the items on your computer that you need. One is the IDE, Integrated Development Environment. Read through this slowly. So you're going to go to this website. You're going to download the appropriate one for your laptop or your computer that you're talking to your card with. So follow those instructions to download it. Choose your operating system. You're going to connect your breadboard to your computer. So let me switch over to the breadboard. So this is your little breadboard. Your kit will come with a cable that plugs into the USB in your computer on one end, and the other end it plugs into the breadboard, like right there. And you can see my other end's already plugged into the computer, so it's got power going to it. So connect your breadboard to your computer. Install your drivers. So take your time, read through this. You might need to reference this website for help, but you'll get there. It's not too difficult. We had I'd say about 5% of students have a little trouble last semester. If you're one of them, we'll help you through it. We have a TA to help a little bit with specifically software installation. But if you take your time and read these steps, most people got it okay. So then you're going to open the interface. You're going to open this software on your computer, poke around, get to know the interface. So read through this manual, do the things they say. It's neat to see the different sections of it in there. Open, verify, and upload. So take your time, read through each one of these lines, but I'm going to hit the highlights right here. You're going to open a code. You are not writing these codes. You can later on, and you can tweak them if you get comfortable with it, but this isn't a programming class. You're going to open the specific code to the numbered circuit we build. I need to go over to the other screen for you. Sorry about that. So I am now on page 7. You're going to open the specific, so let's go back up to where I was. So connect your breadboard to your computer. That's what I showed over the overhead. Open the IDE. So you're going to open that environment, and then this is where I was. open, verify, upload. These three things are the most important things. You're not going to program any code on here. You can if you get into it. You can make your own things, but you don't have to for this class. You're going to open the specific code to the circuit you're building. You're going to verify it, and it just checks it's valid Arduino code. And then you need to make sure you upload it or send it to your breadboard over the cable so that microprocessor gets that code. Follow these steps through. Again, read through slowly page 7, read through page 8. You need to find your board. For these ones, it's not called breadboard. It's the same basic board as an Arduino Uno. So you're going to select that board. And then on here, you need to pick the port that it's talking to. So if you have Windows, if you have Mac, follow these instructions to find the port. The number one issue I've seen is that you try to upload, go through here, and when you're in upload of the code, you get a little error in the bottom, and it's because you selected the wrong port, or it's not trying to talk through the right path to your board. So you try different ports till you find it, kind of thing. So you might have to cycle through, upload, nope, wrong port, choose a different port, go back, upload again to get the code up there. So that's one thing to check if you're having issues. So read through this. Page 9 is get your code. So you have the interface downloaded, you have the board plugged in, it sees it on the interface. Now you need the code for the circuits we're going to build. And you go to this website and you download the code. And there's directions here based on which computer you have to get that code. And then you also want to put it in a spot you can find it. So once you've downloaded that zip file or of code, you need to put it in the spot where then it'll become in the menu in the interface. So follow these instructions here to get that code into the right spot so then you can see it in the interface when you do a pull down menu. So getting started with circuits. So I want you to go through right now, this first week, go through these first 9 pages, get your code installed, and then a little check is going through what I'm going to show you next, is getting the first couple little circuits running. But this is all chocked full of good stuff. What is a circuit? Why do you even care? Oh, we're going to learn in this class about analog, digital, mixed signals, world runs on circuits, simple and complex circuits, cute little cartoon page here on page 11. What does your kit come with? It comes with jumper wires, a whole bunch of different colors, LEDs, light emitting diodes. You get 4 single color ones and then 1 really cool color changing one, which we'll do a lab with. 2 different sizes of resistors, a bag of 25 of each of those. A potentiometer, a diode, a photoresistor, a piezo buzzer, we'll play a little song later, a temperature sensor, transistor, one of 2 types of motors we have, a DC motor, some push buttons, a flex sensor, which is really, really cool. I like that one. A soft potentiometer, it's more like a pressure sensor. A servo motor, different type of motor. A relay, integrated circuit, your board itself, and the breadboard. So the red board, which is the Arduino microprocessing board, and then the breadboard, which is where you're going to put in all your wires and your components, and an LCD screen. So, do your parts check, make sure you can find all of those. It looks a little more in depth of the board. And then it starts talking about some of the inputs and outputs of the board. So you should go in and read just these brief little descriptions. It's kind of useful because I learned a lot about electronics by reading stuff like this. It's not learning from a traditional textbook, but you're learning, you can see the port on the board, you can see what it looks like. Information is embedded within each of these pages. So take your time, read it, find it on your own physical board. You start building a lot of learning through experiential learning this way. The breadboard, you learn about the symmetry of it. So this half, the right and left halves are electrically divided from each other. And even within those halves, like each one of these rows, so like 1, A through E is electrically connected to each other, but not to 2. 2 A through E are electrically connected to each other. But on these side over here at the positive and negative, they're columns. So this whole negative column, which ends up being what you connect to ground, is connected to each other. And this whole positive column, which is usually your 5-volt power source connected back to your computer, is all connected electrically. So this is the top view, and they give a really cool underview so you can see what a breadboard actually looks like underneath. Again, like these portions are each connected to each other across here, and then this whole, what was the column, is connected for the negative and the positive. So you'll learn a lot if you've never broken apart a breadboard, what it looks like underneath from here. And then you're going to do your first circuit. So in reading through the instructions of this first circuit, you learn a lot about how the manual works, about the interface, about the software interface. We're not going to do the programming, but you're going to learn enough in here, and their code is commented so well you can start to program and adjust the programs on your own. So how it works is each one of these is you're going to assemble your circuit, write your code, or in our case, like, maybe adjust it a little, but usually just take their code, and then upload it from your computer to your board. When you get your component, if it's new, you'll have your red board loose and this breadboard loose. There's a sticky piece of tape on the back of this. You can stick it down to this black tray. There's screws that come with the red board. Man, those are probably the worst screws I've ever seen in my life, but do your best to screw this red board down. You might use a different slot than they suggest. Everything else in the kit has been pretty good except the stupid little screws that come with this thing to connect the red board to this black piece of plastic, but that's a personal opinion. And then there's this little warning down here. Your red board's running on 5 volts. It's running on your computer. It's a power supply through a USB cable. 5 volts can't hurt you. Big highlight here. Don't be afraid to touch these components. That's the cool thing about this class is you're going to play with these things. There's no chance if you're just plugging this into your USB of your computer that you're going to hurt yourself with this amount of electricity. So it's a very good hands-on learning experience. You can individually build it, rebuild it. Maybe I've had students fail 4 times, but it was in the privacy of their dorm room. And the 5th time they were so excited because they weren't in the timing of a lab. You can do this on your own time. Leave enough time. You can build it, adjust it, and have successes on your own and learn by reading, doing, manipulating, and getting hands-on circuits experience in here. But not with the, you have 1 hour and your grade depends on it. If you don't get in this hour, sorry, another class is coming in this space. So blinking an LED. This shows you a lot of neat things. Each circuit begins with a description of what's going to go on. A lot of electrical knowledge will be in these little tidbits of information. A little schematic, kind of different than our chalkboard schematics, but a schematic of the circuit itself and how the flow is going. You'll see your parts across here. So the parts you'll need to complete a circuit and kind of an illustration of how it's going to look when it's put together. Some components you'll have to bend the wires on. So like when you get a resistor, you're going to have to do little right angle bends to stick it in the board. And it's okay. So read through this. Don't be afraid to bend these and stick them into the board. And make some adjustments if you need to get your stuff wired up. It's the beauty of this kit is you get some hands-on. They're very tiny components. You got a whole bag of these resistors, so don't be afraid of it. So let's go through and look at this first one here. I'm going to rotate this. So blinking an LED, it shows you how the wiring is going to go for it. LED has a flat edge on it on one side of it, and that flat edge tells you the polarity of it. So the flat edge has the short leg, which is the negative portion of an LED. Diodes are directional, so you need to plug in the negative where they say to plug in the negative and the positive side where they say to plug in the positive. But if it's not, the negative's usually shorter, but also another physical way to touch is you'll feel this little flat face on one side of the LED bulb, and you know that's where the negative is. You're going to put a 330 ohm resistor in there. There's a color band coordination. It's in a labeled bag, but you can also, and we'll go through this in class as well, learn how to read color bands to know which resistors are which. So for this one, it's orange, orange, brown, gold means 330 ohms for a resistor. Jumper wires. So you're going to have various colors. You should have a rainbow assembly of wires in your box. The color doesn't actually really matter. These jumper wires are all just jumper wires inside. Traditionally, you do stick to doing positive as red, that goes to your 5 volt source here, and negative or ground for black, so this negative column going to ground is black. These colors traditionally when you're wiring up don't change. The ones in here, they use different colors, but let's say they had green and for some reason you didn't have a green one in your batch, we'll pick a blue one or an orange one. Try to stick to red and black here for red for positive, black for negative, just to get in good electrical practice. But these other jumper wire colors in the middle don't matter so much. So each one of these is going to have as you go through the manual parts list. So you'll need these certain parts, and then it shows you where to wire them to and from. So LEDs, usually if it has this warning on it here, this little warning symbol that's this yellow triangle, it means, hey, there's a polarity issue. So when I plug in my LED, it's highlighted in yellow. That means I need to check for polarity. It's going to matter where I put the negative component versus where I put the positive component. And I need to put my positive component in C2 and my negative component in C3. And it gives you a little warning in here as you're reading through your manual on it. Your resistors don't matter. There's no warning on here. It resists flow whether you plug it in this way or plug it in the other way. Just one end needs to go into A3 and one somewhere along the negative column. Jumper wire, you're going from ground to the negative column. The other jumper wire, usually use red for the positive column and the 5-volt max source. And then another jumper wire in the middle to go from pin 13, where it's going to be sending out our signal from the red board, to E2 on the breadboard. So you see this red column for the red board, this white column for the breadboard. The white represents connection to the breadboard. So read through these slowly. It gives a lot of information about how this manual is set up, but a lot of information about microelectronics in general for life as you go through here. So when I wire them, I usually follow this, and when you get later, they take these pictures off of where you need to wire so they're not in your way, but this is the first little teaching one. So I'm going to wire one up that's this first circuit for you underneath here. So what did I need to do? I need to take a red wire from the positive over to my 5-volt source. I'm going to take a red wire and go on my positive here over to my 5-volt source. 5-volt source. Sweet, it's in there. I'll zoom in a little for you. There's horrible glare in this room too, so I have this underneath here to reduce the glare. Alright, so I went from there to there. Maybe this light will help. Helps a little. Alright, now it says to go, and we'll go back to the other screen, to go from my negative over to my ground. So, to go from my negative column over to ground. Alright, so I don't know if you can see that. There's the ground portion in there. Just following what's on the board instructions. So if we go back over here, I'm going to take a colored wire from 13 over to E2. And if you're unsure exactly where this is on here, remember it references over here. So pin 13 to E2. So let me do that over on this side. Grab a green one. I'm going to go from pin 13 over to E2. Alright, looks good. What else do I need? Let's make sure I didn't forget anything. Alright, so I got these 3 wires done. I need my LED from C2 to C3 with the positive in C2 and the negative in C3. So I'm going to grab a yellow LED here. Let's see if I can get this under focus for you. There is a flat side on here that you can feel. My flat side is right there. It's hard to see. Maybe I can get this to refocus on the light. There we go. There's a flat side right there. An easier way is to look at the relative lengths of these 2 pins. So the shorter one was indicated as the negative polarity and the longer one is positive. The shorter one is supposed to go into C3 and the longer one into C2. So I'm going to put this longer one in C2 and the shorter one in C3. So longer one in C2. Shorter one in C3, so my little LED in there, and it is directional, so one thing is if it doesn't light up, diodes are directional, you might have it flipped and you need to just turn it around and plug it back in. If we go back over to a manual for a second, the other thing we need is this resistor, and resistor directions don't matter. The resistor needs to go from A3 to the negative, so we need to complete our circuit here. go from A3 to the negative. So I think I had a resistor out. There he is. So again, these resistors, don't be afraid to bend them. So you're going to bend it a little bit here, bend it a little bit here. Not the most beautiful right angles, but it'll work. Alright, so we're going to go from A3 to somewhere in our negative column. Yay, and he's on. Awesome. So we have a light that's working. And try to move these wires out of your way so you can see what's going on here. So it goes from A3 to negative. And then our circuit is complete there. Now usually it doesn't light up right away. This first circuit almost always lights up right away. It doesn't mean your code's working right. There's another verification you want to do to double check that your first circuit code is working right. So got it wired, it's blinking. Now we're going to do a little more on the code side, which is what you're supposed to do after you have it built, is go to this portion and open your code. So it says open your first sketch, follow these directions. So we're just in the same, sorry, let me go back to the other view for you. Okay. All right, so in the computer view, once you have it going, and we just did that build on page 2021, it says open your first sketch. So you go in and open your Arduino code and look at your first sketch. And it talks about opening, verifying, and uploading. So I'm going to go over to that so you can see it. So this is the Arduino interface. I've opened up circuit 1. So again, though, if it's file, examples, and this is on a PC, I'm running this demo. When I put them in the right spot, they showed up here as code. This is circuit 1 blink. So I'm opening that code. Remember the important steps is open it. Awesome, I found that code, I opened it. Verify is right here. Verify, make sure this code is proper. It's not talking to the board yet, just making sure all your parentheses, semicolons, everything in the right spot. Okay, awesome, my code's good. And then upload is sending it to the breadboard. So if you hit upload, it's going to try to send the code. If you don't get any errors down here, it means you picked the right port and everything. If there is like an orange bar that comes up down here, you might want to look under Tools and look for your port. You might need to choose a different port to actually find the one that's talking to your board. Okay, and make sure your board's plugged into the computer while you're doing this. So I've just uploaded that code to the board. I'm going to do the same process of verify and then upload, but I'm going to show you the other view now. So I'm going to go through as it looks at it. I mean, it's already running if it hadn't had the code to it. I'm hitting verify right now. It's just rechecking the code. And then when I hit upload, I want you to look at these lights. As it's uploading, you're going to see on the board here that the board is receiving the code. So when I hit upload, it blinks. The other lights blink, and it's getting the code from it. So that's how you know your computer's talking to it and uploading that code. And then the best check to make sure everything's working is, okay, I got light 1 blinking. It's like a 1 second on and off blink in circuit 1. Read through the code itself. So let me go to the code itself. This code is awesome because if you don't know anything about programming, you can start to learn a lot from in here. So you're going to turn on an LED for 1 second, off for 1 second. The code is in here, but then it gives good comments through here of what each line's doing. So you're turning on the LED here, you're waiting for 1 second or 1,000 milliseconds here, you're turning off the LED here, you're going to wait for 1 second. We're sending a 5-volt digital signal. High means those full 5 volts. So you're turning it on with the full 5 volts. Low means 0. So for digital, it's on or off. 5 volts or 0. So we're sending 0 here that turns off the LED. And then the delay that's built in is wait for 1 second. So it gives some suggestions down here. I want you to try this first one to make sure code's working. Try changing the 1000 and the above delay functions to different numbers and see how it affects the timing. Smaller values will make the loop run faster. So let's change our delay, and this is the best way to check that your code's working. So I'm going to go in, instead of 1,000 seconds or a 1 second delay, we're going to change it to blink at a different speed. So first let me switch over, and you can see it's blinking on, off, on, off, on, off. You have a 1 second delay. So let's go back over to the code. And what you can do is just go in here and we'll change it to like, let's do 300. See what happens. And so since I changed something in the code, I'm going to re-verify it, hit that check mark. It's going to check my code. My code's still good because I didn't erase any of these, parentheses or anything. I just changed those numbers. And then I'm going to hit upload. But before I hit it, I'm going to switch the view back over so you can see what's happening. And we're going to see in changing this to 300 how it changes our blinking speed. So, and this also checks to see if your code's working all right and you got everything talking to it. So we have this was the code from the 1,000 milliseconds or 1 second blinking on off. I'm going to hit upload right now and you should see these lights light up that the code's going to it. And then hopefully some change in the blinking speed of this. So it's getting new code. There we go. Now we have a 300 microsecond or 0.3 second delay. So it blinks much faster. And if you can do that and change that code and upload it and see a different blinking speed, you're in really good shape to know that your computer's talking to your board, you can get the components to talk to each other, you can find the right ports, and you can send new code to it. So if you can get circuit 1 running with not just the initial code, but with changing it to do this other faster blinking speed, and going over here and re-verifying it and re-uploading it and seeing it go to your build itself, see the lights light up, and then change the blinking speed, you're in a good spot for having your kit up and running. So I'm going to leave it at that for now, but go through, this goes through about page, where were we? 24 of your guide, so that's your first real item to read, is go through page 24 of your guide, take your time, read through it, get your code running for circuit 1, and make sure you can change the blinking speed on circuit 1 as a good first check that your kit itself is running and that you feel good about these components. And as you read through this, you're going to read a lot about digital electronics, and you're going to gain a lot of knowledge into physical aspects of circuits as you read through this guide and get good practical knowledge for things other than just doing book problems on circuits. So I'm really excited. I love this kit. It's fun. Students had a really good time with it last semester as far as walking away with practical knowledge. This first one's blinking an LED, but it's also how to adjust the code and get it loaded up. And then from there, we're going to go to motors and diodes and buzzers and flex sensors and LCD screens that you start to get a feel for components you might use in your field as an engineer, in your personal life as an inventor. But we're going to go through a number of these 16 circuits, but not all of them. And please get circuit 1 running, change the blinking speed, and you should be good to go then for feeling comfortable that your board and your kit is set up properly. All right, guys, we'll stop this one here for now and get your kits going and let us know if you need help with anything.